Hello, my name is Jawad Saadi and I'm the Managing Director of Hexatronic Security and Surveillance. Today we're going to speak about the InOne solution. It's a solution that is hybrid power and fiber system. So let me start the PowerPoint and we talk about the agenda of today. After this introduction, we're going to go directly into the main presentation, describe more about the solution and see some applications where you can use the InOne. Then we're going to do a hands-on demo. I'm sitting in the InOne studio, so we're going to show the product. Then we're going to have a little bit of a talk of the savings that you can do when implementing InOne. There will be a case study that is linked to this video about one of the projects that we implemented in ILA. And then we're going to talk about how you can become a partner to us, how you can become a reseller to the InOne solution. Hexatronic Security and Surveillance is a company within the Hexatronic Group, a group of over 20 companies. 7 years ago, Hexatronic have acquired the Ericsson fiber optic business, the cable factory in Hudiksvall, and then we've added many companies into the group with specific specialties in niches that has to do with the fiber optic industry. Our company, Hexatronic Security and Surveillance, we're focused on the InOne solution and we work a lot with the security and surveillance industry. But let's speak more about the product. First, let's speak about the background. PoE, Power over Ethernet, is a standard that many of you are familiar with. It started almost 20 years ago and it's an amazing standard. It's been adopted by many industries. The power started with 15 watts with the PoE, then with the PoE Plus, it increased to 30 watts, and with the PoE Plus we have 60 to 90 watts, which is amazing. It's a lot of power on the Ethernet cable. The limitation that didn't change throughout the years is the 100 meters limit, and everybody would like to have that extended. There are some PoE extenders that takes you to a couple of hundred or few hundred meters, but how about kilometers? And this is where the InOne comes in. The InOne comes in that it allows you to push the industrial switches that provide the PoE ports over your network over kilometers of distance. And you need the InOne solution in many applications, whether you're using PoE or you have devices that work on DC power and they can take direct fiber. So, in the core of the solution is this hybrid cable. We have done this hybrid cable, which has power and fiber both inside the same cable. It's a micro cable, so it's very easy to manage and it is blown in the network. So you can blow it in microducts and it's a very easy installation. But we're going to speak more about this. But this is in the core of the product is this micro hybrid cable. So how we design or how is the network looking like for the InOne? In a central point, it could be in your data center or a starting point. You have, this is where all the cables are connected. We convert the AC power to DC power. And DC is the secret how we can have these compact cables. There are many advantages for using DC over AC. In the end of the day, your devices are working on DC. So instead of taking the AC all the way to the devices and putting AC to DC converters next to the device, we actually do the conversion in the data center in the beginning of the network and we transmit DC. The big advantage of doing that, you can have these compact cables. When you're using AC, you need to use much bigger cables and it will be far more expensive to do that. Then we go out in the network and we connect devices in different locations, and we'll speak more about the network topology. So let's look at in the centralized location. We call it the hybrid distribution node. First, as mentioned, we convert the AC to DC and we use the 110 volt European safety standard for the DC. By standard, we can use up to 10 amps. So we are using all of that power. We have different sizes of rectifiers, 1000 watts or 480 watts. Then we take the DC out from that AC to DC rectifier into the hybrid ODF. We combine the fiber that is coming from the core switch in the hybrid ODF with the power, and they both go on these InOne hybrid cables. Now on the other side of the network, the access network, so now we run the cable for 1 kilometer or 2 or whatever is the distance, and we're going to speak more about the distances. And here we split the power and the fiber. The power have arrived a little bit less than 110 volts where we started because there has been losses in the network. And now we have a voltage regulator, and the voltage regulator converts DC to DC and gives me regulated 48 volts that we input to the switch. Then we also take from the cable a couple of fibers and we splice to the switch, and then you can have PoE devices connected to the switch. And now, after you have reached the kilometer or the 5 kilometers or the 7 kilometers with the distance, now it's okay that you have the 100 meters for the PoE standard. So you connect your devices with a Cat6 cable over PoE. If you have a device that has its own SFP, you can do without the switch and connect the fiber directly to your device, and we supply also the 48 volts. So the cables, we have different variations. This is the medium of the 3 variations that we have. The variations are more copper and more fiber. So if you need to reach more distances or you need more power, then you use the bigger cables. One of the good things with the InOne cable that we rely on the big portfolio of Hexatronic with the ducts. And we have different ducts depending on your type of implementation. And let me pick a couple of samples from here. So usually you use these single ducts. These are direct burial ducts, and the cables are blown inside these ducts. You can use air compressors to blow it, but then we have like a 2-way duct. We can have up to 7-way duct. We have ducts that are armored for underwater installation, or if you need any specification that requires that you have an armored duct. And we use these quick connectors to connect the ducts during the installation, which is extremely easy. This is a huge saving in the implementation. So you save because it's so much less infrastructure, civil work, it's so much less civil work. Then you have one civil work and one infrastructure for both the power and the fiber. Then these ducts can be put in micro trenches, which is an extreme saving as well. And we have a detailed video on the savings due to using the hybrid cable and the micro cable and using it along with the ducts. So you can refer to that video as well. The InOne does not have any limitation on the network topology that you use. You can install the access cabinets, the access nodes. You can install them in a bus topology, in a star topology, in a fan out, or in a ring topology. The added advantage of using it in a ring topology that you get redundancy against cable cuts. So if there is any cable cut in the ring, then you have redundancy for both the fiber and the power. And this is a huge advantage because you cannot actually achieve ring redundancy with AC power cables. So this is a very big advantage for when using DC. One of the extra advantages that you can put it in a ring topology and have a redundancy against cable cuts exactly like we do it in fiber. Now a big question always, how far can I put my devices? How many devices can I put? What's the maximum power load? So actually it's a power budget. So we mentioned in the beginning that it's 110 volts DC and 10 amps. And then you use that and you put more devices or you go longer distances depending on the power budget that you have. For that, because there are many parameters, we have created a design software that you input the distances and the loads, and it gives you how much power you have left in your power budget to see if you can put more devices. So if you give us, for example, the network layout on an AutoCAD or a kind of a schematic that shows the distances and a table with all the loads, we can help you with that design as well using our design software. In a typical network, this is an average from some of our projects. You have more than 50% goes to the infrastructure, the civil work, and the cabling. Then you need a kind of edge switching. Then depending on your application, in this example we're using CCTV, you have some device equipment. It can be radios, it can be anything, the devices. Then you have a kind of software. When you implement the InOne, you see that you have an immediate saving on the turnkey project. The software and CCTV, we assume that they remain the same, so there is no savings there. But the big savings is in the civil work and in the cabling, because the InOne is 2-in-1. This is where the name comes from, the power and the fiber. So you have one network, one cable instead of two, one civil work instead of two, one excavation instead of two. The saving is in the civil work. And in our solution, we actually embed the industrial switch. So the access switches becomes part of the InOne. So if you're a system integrator and you have a turnkey project, then you can reduce the total cost of your project. You can become more competitive without putting pressure on the margins of your devices and the software. So let's try to summarize. What are the benefits of the InOne? We have big claims of the savings. We like to be challenged on that one. Bring us your projects and we'll show you how much savings you can achieve. It all depends on the civil work and the routes of the civil work, but we have big claims. We claim that you can do 50 to 70% saving on the cabling part and the civil part. Speed of deployment. Because we're using the blown fiber, because we're using micro trenching, then everything can go much faster because much less civil work. And with blowing the cables, that's the fastest way known today of deploying cables in ducts. Security. And this is a point that I need to mention now because I missed to mention it earlier. In many cases, the InOne works. I mean, if you don't have power for your devices, the InOne is a perfect solution. But in many cases, you do have power, but it is not your power. It's not secure power. So you're probably sharing the power with the lighting system. And if you have a critical application, you don't want to do that. You want to have your own power, your secure power. So this is extremely important. Some of our customers are only using the InOne solution for the security aspect of the InOne. And this is, so if you're deploying fiber optic for your devices, you might as well use the InOne cable, and it's the same deployment, it's the same network, everything is the same. We're just using a different cable, but then you get the fiber and the power. So this is a big point. Redundancy. We have two redundancies here. We talked in the ring topology about the redundancy against cable cuts, but also we have redundancy against power failure, because now the UPS is put in the central point. So you have one UPS for the whole network that is inside the starting point, inside your data center. Traditionally, people were putting the UPS out in the field. Then they need more expensive UPSs that are certified for external environments, IP65 or whatever standard that you are following. And you need to have many UPSs. In this case, you only need one in the beginning of the network. Flexibility. And this is when we mentioned about the different network topologies, that it's flexible. You can install it in many different network topologies. What's coming in our roadmap? first, we have a bigger cable that's already launched. Then we're having more power inside the cabinets to accommodate devices that are power hungry. We're going to also introduce new power levels. Today we have the 48 volts. We're going to introduce the 36 volts and the 24 volts. They're all DC, of course. Then we're looking at quick connectors for fast deployment and redeployable deployment. And it will be hardened, so it will be good also for harsh environments. And we're looking for a tactical solution for where you can redeploy the solution with meeting all the tactical requirements. So the InOne, as mentioned, we are indifferent of what application that you use the InOne for. But let's look at some applications that we have been engaged with customers about different applications, and the list of applications is actually growing by the day. First, and this is probably the largest segment of our customers, is perimeter security and CCTV in general. When you deploy CCTV cameras outside buildings, in perimeter security, in border control, city surveillance, power is always the issue. I mean, with data, you can have fiber optics, you can have wireless, but with power, it's always very expensive. And to have secure power and redundant power, that is even more expensive if you do it in the traditional way. So the InOne is a perfect fit. And again, give us your projects, let us do the design, and you will see the value financially and with the features of the solution. Second is public Wi-Fi. Many municipalities are requesting that there are public Wi-Fi's in park or public places, and operators and service providers are finding the InOne is a very good solution for deploying public Wi-Fi because it achieves big savings and it achieves the security and redundancy that we mentioned. A very big industry that is coming up is 5G. For microcells, small sites. A typical 5G small site will have a power consumption of 60 to 70 watts. Some models that we have seen are even less. And then again, the InOne is a very good solution for deploying 5G small sites. Other industries like DAS, distributed antenna systems, and RF over fiber. In DAS and RF over fiber, what is common that you want to have the antennas away from your radio base station, and then usually you connect your antennas with fiber, but then you need to source the power locally at the antenna. And in many cases, you don't have power where you want to install the antenna. So the InOne also works perfectly with that. We have also customers that are using the InOne with microwave relays. So they use the fiber as a backhaul connection for the microwave link, and the DC power to power up the radio. Many of the FTTH providers, it's a very big cost in many cases for them when you go in the rural areas to connect the last homes. So they use usually radio, broadband over, wireless broadband, and they use point-to-multipoint radios. So they use the InOne to connect the point-to-multipoint radio, and then they use wireless to connect the last homes. This is an interesting case. We worked with a customer in Norway, and they're in the fish farming industry, and they have their devices, all the devices in the float. And the issue they had there that they could not get a stable radio connection because of the tides. So they used the InOne to power the radio and have the fiber connection, and they installed the radio on land. And they used the InOne. We showed the submarine armor duct in that they used that one to deploy the fiber inside it, and then they connected the radio that is on land. So an interesting application. In smart cities, you have all kinds of devices, whether the ones that we mentioned, CCTV cameras, public Wi-Fi, or other devices, air quality sensors, LoRa base stations. So you can use the InOne as a multi-application infrastructure that provides power and fiber to all kinds of sensors. Also, FTTH operators, we've seen some cases where they are interested to provide a new service, which is a powered VLAN port. So they get customers that they want to connect different devices in different parts of the networks. So they provide them, instead of just providing them the fiber, now they can provide them a PoE port, and they use the InOne to power those industrial switches, and they sell that as a service. Also, again, with FTTH, if you deploy and this is a case that we have worked with a customer in South Africa, that they're deploying the FTTH using GPON along with a CCTV deployment. So they use the InOne cables, and the InOne cables, they were feeding the industrial switches for the CCTV, but also they were the feeder cables that they connected the splitters and then drop cables to the home for the GPON connection. So the GPON and the InOne became one infrastructure, and there was a huge saving in that design. The last application, this was a customer that this was totally off-grid, and what they used, that they put on every pole, you can see in the bottom picture, they put on every pole a radar sensor, a PTZ camera. Then they needed power, so they put a solar cell and a UPS, or a kind of a battery system. Then they needed data connectivity, they put a radio. And then all these 5-6 devices, they replicated everything on every single pole. And when they came to us, we said, if you're off-grid, where would we bring the power from? And then it was obvious that why don't we consolidate all of these and have one centralized solar panel, one centralized UPS, one centralized radio, and then use the InOne to connect all the cameras and radar sensors. So this was really very interesting. It's not only a saving, but in this case, it was 45 poles. So you have reduced the service point for the solar panels and the UPS from 45 locations to one location, from 45 locations that are up on the pole and very hard to service. I think you see the benefit in that one. This concludes my slides. Now let's look at the product itself. So if you remember that everything started in the data center, in the hybrid distribution node. And this is an example of a hybrid distribution node. You can have this inside your data center. You can also have it in a street cabinet. And these are the components. The components, we have an AC to DC rectifier. So we take the normal AC and we take DC out, in this case 110 volts. Then we have this fiber that is coming from the core switch, entering the hybrid ODF, and then the power and the fiber is exiting the data center using the InOne cable. Two more things I would like to add here. You see that we have put the UPS in this centralized point. So now we're protected against any power failure. And also you can add a controller and put two rectifiers for redundancy. So this is an extra level of redundancy. So this is the hybrid distribution node. Then we have deployed the cable, and in this showroom, we have moved all the way to the other side of the room, and this is where we connect our devices. So this is what we call the hybrid access node, and we have two sizes. We have the bigger one and the smaller one. We call this the E10 and the E3. All right. So let's look what's inside this cabinet. Let me bring the camera a little bit in so you can see a little bit better. So you see here, I have the incoming fiber cable. I have also here 2 outgoing cables in case that you have other devices, other cabinets in the network, and you could go out in a star or in a bus topology. And now we have splitting the power and the fiber again. We're splitting the power here. Yes, this is better. We're splitting the power here into this power circuit. Then we're looping out the power to the outgoing cables. Then the input power for this cabinet is going to a protection circuit, and then it's going to a solid state industrial grade DC to DC voltage rectifier. So if we have reached this point, if you remember, we started with 110 volts DC. Let's assume that we reach this point with 95 volts, but we need 48 volts for the switch. So now we take this to the voltage regulator and we output the regulated voltage here. The fiber, we take the fiber to a fiber cassette, then we take the fibers to the switch. All right. So here you can see the fiber that is going to the switch. Here we have a big variety of different industrial switch. In this case, this is a 6-port switch. We have the fiber in and the fiber out, and we're taking the Cat6 cables out from the cabinet going to the devices. One thing I need to mention, that all this cabinet and yes, all this cabinet is all enclosed in this cast aluminum cabinet, and this is to manage the heat. Everything in this cabinet is industrial grade. Everything is solid state. There are absolutely no moving parts, and everything is managed in a way. Even the DC to DC voltage regulator is pressed with a heat pad on the back of the cabinet, and we use that for heat dissipation. The other cabinet, functionally, it is identical. It's a smaller form factor, and customers that do not need a switch or they just need a media converter, they can use the smaller form factor. So this is a quick tour in our InOne studio. One thing that if you go to our landing page, hexatronic.com/InOne, you get a link that you can book a dedicated demo in this demo room. So please feel free to use that. Okay, so now we're going to go to the next part. How do you partner with us? It's easy. There are 3 easy steps. All right, you register. Here is the QR code. You can take it now or later. You register your company with us. Then you attend the sales training and you order a reference system. Then you get the price list and you get everything. So there are 3 easy steps that you become an InOne partner. What do you get? You get from us project design using the design software that I mentioned. We share leads. We get leads from different countries, so we can share leads with you. You get prioritized support. Of course, you get partner pricing. Now, when you become a partner, you get partner pricing. And we do shared marketing activities. You also get access to this online showroom. In the design, what we request from you or from the customer is a kind of a layout, whether it's on Google Map or a kind of schematic that shows where do you want to have the devices, and it should be to scale so we can measure the distances. This is the only thing that we need from you. What you get back from us, you get a full design with single line diagram, how everything is connected, and the routes that we are using. You get an output from our design tool, how the loads were calculated and the power budget and how much redundant power you have for future expansions. You get a power distribution table, so you know exactly how's the power consumption distributed on the different systems. You also get a bill of material. So you get a lot in the design. Then you also get in the solution description, you get what redundancy options do you have if you haven't requested redundancy, what are your expansion capacity for future expansions, what are the savings that were achieved, and we can do that if there was an alternative design in a traditional way. If there is anything not clear in the input, we try to clarify it. Otherwise, we write up our design assumptions. We suggest any optimizations. Sometimes the customer requests things in a different way. So we suggest optimizations. And upon the design approval, we can also generate AutoCADs that can be used in the deployment. Thank you so much for your time. We're doing more videos, more in-depth of specific things. The most important thing, register to become a partner. For end users, speak to us. We can guide you into one of our partners that are working in your country. Please feel free to use the link below to book this demo room for a dedicated session, and I hope to hear from you soon. Thank you so much.